All right, students, we're going to be covering Module 7, Homework 4. So in this lesson, it's all about complex fractions. Now, complex fractions scare people because first, they don't even like fractions to begin with. And then they just have a tendency to start shutting down when it comes down to it. But I mean, I want to look at fractions where, if you have a fraction on top of a fraction, sometimes it's nicer to write it a little differently. And here's what I mean. Sometimes students like to look at it this way, is that it's 7/9 divided by 13/15, rather than writing it where it's stacked. And then we remember from fractions and when we were kids, is that we keep the first one the same, change from division to multiplication, and flip the second fraction. So KCF, Kentucky Chicken Fry. All right, so I always joke around with kids. They all like, "What are you talking about?" Yeah, I know. So it's a little dorky, but now when we look at this, we can go ahead and treat it like this, and we keep, change, flip, and then we go ahead and look at this in respects to, well, when we see a 9 and a 15, 3 can goes in both of them. So 3 goes into 9, and it goes into it 3 times. 3 goes into 15 5 times, and 7 and 13 can't be reduced because nothing can go into both of them. All right, a single number can't go into both of them. So all we're left with is then 7 times 5 is 35, and then 3 times 13 is 39, and there's our answer, and we're done. Okay, not very complicated, is it? All right, so we can go ahead and use that strategy if we so desire. Okay, because it's a fraction divided by a fraction, and that's what answer we get. Okay, now when we're doing this, okay, we can continue to process it this way, but I'm going to venture into another strategy in just a minute. But I do want to reinforce that this way is not a bad way, that we're going to go ahead and just copy the first fraction, change from multiplication to division, and reciprocate the bottom fraction. So the bottom fraction then becomes 7y to the 7th on the top, and then we would put the 55 x to the 3rd on the bottom. So KCF, keep, change, flip. So now we look at this and we see that 7y's takes away 7y's here, leaving us with 1y. 3x's here wipes out 3x's here and makes it become 2. 11 goes into 33 11 times, or excuse me, 3 times. 11 goes into 33 11 times. I don't think so. We have 3. And then 11 goes into 55 5 times. So when we look at this, then we have 3 times 7, because by the way, 2 and 7, we can't do anything with that, right? So we have 3 times 7 is 21. And then we have an x to the 2nd power on the top. And then we have 2 times 5, which gives us a 10. And then we have 1y left in the bottom. And there's our answer. Now, you don't need to put the 1, by the way. Okay. Now, some additional properties. So you have that property. You could do that property throughout if you wish. I want to go ahead and give you some unique other properties. Okay. Now, when we're looking at this as a fraction on top of a fraction, okay, and notice how they bolded that line here, which is a good thing that they bolded it. Whenever these are the same, these right here, whenever they're the same, they go ahead and are completely gone. And that leaves us with 2 over 12, which reduces down to 1/6. And I'm done. That's my answer. I love those questions. So if that's the case, my answer for this next one is x plus 4 over x minus 5. I'm done with that one as well. Okay, I am so on top of that. Talk about less writing on this one. Okay, now some of these, this looks like a little bit of a hot mess because now we got fractions with fractions and whole numbers and everything else. So this becomes a little bit more interesting, to say the least, right? All right, now I'm going to go ahead and show you another strategy. Whenever you have a fraction that includes a fraction like this, we can go ahead and kill fractions by multiplying by the denominators or the LCDs of denominators, because you can have multiple denominators. So what we have here is a fraction with 1 over x. If I multiply this bottom by x, I would wipe out this fraction with a x in the denominator. But what I do to the bottom, I must do to the top. So I'm going to have to multiply both the top and the bottom by x, and that means x over x, which is 1. So I'm not changing the value, I'm just changing its appearance. So what we end up with is x or 5x's, because x times 5. And then I'm going to distribute the 1x to x over, or 1 over x, which would mean 1, plus, and then the x times the 2 gives us 2x. And there's my answer. I am done. So that is a very powerful strategy that I just gave you there. Okay. Now let's take a look at this one. It starts to look a little bit busier. Now, if we keep in mind, we're looking at the denominators and we're trying to eliminate all the denominators, we'd have to find the LCD. So what we would need is an x, and we would need a 9 and a 5 in order to eliminate them, right? So when we do that, right, in order to eliminate all the fractions, if we really literally wanted to write it like that, that would be a little bit weird, but we could write it like this. Excuse me. I'm literally not multiplying them out on purpose to show you something. So this is the LCD of x, and you have both of them have an x, and then the 9 and the 5, right? Okay, now what I would go ahead and do is multiply this times this, and these would knock each other off, leaving me with 9 times 5 times 1 is 45. And then I would go ahead and knock out the 9s, and then it would be 5 times x times 4, which would give me plus 20x. And then I would do the x's wipe each other out, leaving me with 45. And then I would have the 5s knock each other out, leaving with 9 times x times 4, which is plus 30. Well, I don't need a plus, but or I could put plus. It doesn't make a difference. Okay, yeah, I would need a plus. Plus 36 times x, and then I'm done. There's my answer. Now I could clean that up a little bit if I wanted to. All right, but here is the answer that I just gave you. Okay. Oh, hold on. 9 times 4. How did they get the? I see 40. Maybe I missed something here. Did I mix? No. Oh, there it is. There's a 6 here, and I put a 4. All right. So I did make a mistake in my transcription here. That should be 56 because we have 54. Excuse me. What the heck? I'm thinking of something else. 54. Okay, so it's 9 times 6. I've had a transcription error. Okay, so yeah, when we do this, okay, we're going to go ahead and just think about what the LCD is for this. Okay, so we go ahead and continuously multiply by the LCD. And now I made it broken up here and make it really simple for you guys. Okay, So I'm going to practice that with you guys, and I'm going to do the same idea over and over again. So I look at my denominators, I see that I need an x minus 1 and an x plus 1 in order to eliminate all the fractions within these complex fractions. So I'm going to put x minus 1, x plus 1 on both top and bottom. And then I would go ahead and distribute it. So I would distribute it to all this, right? So I'm distributing it to the entire thing. So when I distribute this, I'm going to get 4 times x plus 1. And then I'm going to go ahead and distribute this out to here. And this will wipe this out, leaving you with this times that. So that's going to be -2 times x minus 1. Now I just distributed that. Now I do the same thing to the bottom. And then I'm going to wipe this out. I'm going to put x times x plus 1. And then I'm going to go ahead and wipe this out, leaving you with plus 1 times that. So positive 1 times x minus 1. Now I'm no longer having to look at complex fractions. So I'm going to do the distributive property and combine like terms. So I'm going to do 4x plus 4 minus 2x plus 2. That's going to be the numerator, or excuse me, the numerator. And then I have x squared plus 1x plus 1x minus 1. So my final answer will be, if I look at this, 4 minus 2 is going to give me 2x. And then 4 plus 2 is 6. And then I have x squared plus 2x minus 1. Now, I can factor out a 2, but it's not going to clean anything up. I don't need to factor this any further. I'm done. There's my answer. Okay, here's our answer that I gave you. Okay, this time without a transcription error that I made. Okay. Now, whenever we see negatives, this is what we see. That's what we see when we see negative exponential powers. Okay, they are in the form of complex numbers for that reason, complex fractions. So we're going to multiply both top and bottom by a squared because the bottom has a squared in it. So by doing that, we're going to get 2a squared plus 4a all over. Oh, stop it. And then we're going to get 1a squared minus 4. Now I'm going to go ahead and factor a little further. I'm going to factor out a 2a just to make sure that everything's okay. I'm going to go ahead and do that. And then I go ahead and factor this out, and I'm going to get a plus 2, a minus 2, and I see that these two can cancel each other, which is why I saw that it was going to be able to be scratched. So we still are applying ideas of what we've done in the past where we factor to reveal to simplify. So we're going to have 2 over a minus 2. Okay. Where did I go wrong there? Oh, yeah, there's 2a. I had A. You mean, yeah, Ryan. Yeah, right, Ryan. I meant to put the A and I didn't. Okay, so obviously we factor an A between that. And I even said it, but I didn't do it. Darn it. All right. So we have our answer here. That should be 2A. Okay, so that's why we have the 2A in there. Okay. Now let's take a look at number 9. Okay, so we have 5 plus 45 over A. And then we have 1. This one almost is feeling like the last one we just did, doesn't it? Where we're going to multiply both top and bottom by A squared. Okay. Now, with that being said, we're going to go ahead and I'm kind of crashing in this other problem, and I'm going to erase this part, okay? Now, I'm going to go ahead and FOIL that through, excuse me. I'm going to get 5A squared, and then I'm going to get plus 45A. It feels like we just did this one, just different numbers. A squared minus 81. And then we factor out a 5A. This time I'm not going to mess up the A. Look at that. I remember that now. I made that mistake. I'm not going to do it more than or again. And I'm going to get this. And then I'm going to go ahead and get this. Wow, this feels like the same exact problem except for different numbers. And then this cancels this out, leaving us with 5A over A minus 9. All right. That one felt exactly like this one up here. All right. That's true, Ryan. I got to redeem myself. You're such a clown. I love it. All right. So now we have 3 minus and then 7 over x plus 5. And then we have 9x over x plus 5 minus 2. So my LCD is going to be x plus 5 for both top and bottom. I will multiply that out. All right, and then I'm going to get the following 3 times x plus 5. And then I'm going to go ahead and get minus 7 because these will cancel each other when I FOIL it through. And then I do that, I'm going to get 9x and then minus 2 times x plus 5. Due to distributive property and combine like terms. Okay, so I'm going to get 3x. And then I'm going to get 15. All right, and then 15 minus 7 is 8. Over, and then I have 9x minus 2x gives me 7x. And then I have negative 2 times 5 is negative, negative 2 times 5 is negative 10. So here is my answer for that. Hey, I'm getting them right. Woohoo! That's a good thing, right? I should be getting them right. The only time I don't get them right is when I'm making it go too fast. All right, now. I hate my chair making all this noise. Stop making the noise. I'm going to have to oil it. You know, the Tin Man in Wizard of Oz needed some oil. My chair needs oil. It's popping. All right. It's because I'm getting too heavy. Oh my gosh, I can't stand it now. It's annoying me. Sorry for those of you who have to hear me complain about my chair. Okay. Now that was a lot for me to write, but I had to go ahead and look at it. Now, thing is that I got to look at this in the terms of how many I need of everything. So I need m to the second power to wipe out m's for both top and bottom. And then I need n to the second power to wipe out n on both top and bottom. So I'm going to multiply both top and bottom by m to the second, n to the second. And then when I do that, this is going to cancel this out. And then this n will wipe out 1, leave me with 3n. Then I hit reset and I do that again. This will cancel out all of this. And then one of these will be wiped out, leaving me with an m. So m times 8 is going to give me 8m. All right. Now I do the same thing for this right here. Okay. So this will wipe this out, leave me with n times 12, or 12n. And then I have the same idea. This will wipe this out. And then one of these will wipe this out, leaving me with 1m times 1, which gives me this. And here's my answer. All right. That's how fast this works. The hardest part is writing it down. And then we have the last one, 11 over x plus 6 over x plus 1. And then you have x plus 1 in the bottom. And you have 1. All right, now what we need in order to kill off all the denominators is an x and an x plus 1. Okay, now that I do that, this will take this out, leaving me with 11 times the x plus 1. And then this will wipe this out, and then it'll be negative 6 times x is negative 6x. And now this will wipe this out, leaving me with 1 times x, which is 1x. Now that I have that, I'm going to go ahead and do the distributive property combining like terms. So 11x minus 6x's gives me 5x's plus 11, because I got to do the distributive property. So 11 times 1 is 11. And then all over x. I think the hardest part about this is understanding how to find the LCD. All right. And that concludes this lesson. Okay. That's pretty straightforward. Sometimes you just got to make sure you don't make a transcription errors like I did a couple times in here.